Okay, hello everyone. Let's go ahead and take a look at scale factors. Whenever we want to represent an object using an enlarged or reduced image, we need to maintain the relative size of the image by using what we call a scale factor or scale ratio, which describes the amount of enlargement or reduction in ratio form. So let's go ahead and take a look at what scale ratio is. Scale ratio is a ratio without units in the form diagram length to real life length. Okay, so let's go ahead and take a look at an example. Here is a very simplified rectangle here, and let's just say that the diagram length, which is of course this length right here, is going to be 1 centimeter long, and let's say, for example, that the real life length is actually 1 meter. So for every 1 centimeter, the actual length is actually 1 meter. So now notice, if I wanted to go ahead and calculate what the scale ratio is, the scale ratio is basically this, right? Scale ratio is equal to this, so this is your initial statement for scale ratio. It is going to be the same thing as 1 centimeter to 1 meter. And we know that being that these are different units, we need to go ahead and change it so that it's the same units. So I have 1 centimeter now to 100 centimeters because that's what 1 meter is. And now I can disregard the units of measure, and I can say then that the scale ratio is 1 to 100. Now, the scale factor, how do we go about determining the scale factor? Now the scale factor, again, remember, is the number the diagram length must be multiplied by in order to obtain the real life length. So if this is 2 centimeters, then of course I need to go ahead and multiply that by 100 in order to get 200 centimeters, which represents the actual length of 2 meters. So notice that the scale factor then is really going to be the real life length divided by the diagram length. And that is going to be your initial statement, okay, for scale factor. It is going to be equal to the real life length divided by the diagram length. Okay, so given that the case, then we know that the scale factor is obviously going to be 100 in this case. Now, let's go ahead and take a look at a question that I want you to go ahead and think about. Being that we're dealing with reducing or enlarging an image, if your scale factor is greater than 1, what happens? Is the real life image larger than the diagram image, or is it the reverse? What happens when your scale factor is between 0 and 1? And what happens when your scale factor is 1? Okay, these are some questions that I'd like you to go ahead and consider for us to discuss the next time that we come to class. Okay, now let's go ahead and take a look at an example though. Let's say, for example, that our scale ratio is 50 to 3. Okay, the diagram is 150 meters long, whatever that length, whatever that object is. And we want to ask the question, how many meters is the actual length? Now, remember that our initial statement, that the scale ratio is equal to the diagram length over the actual length. So what I'm going to say then, if that's the case, I can say that therefore 50 to 3, which is the diagram length to the actual length, is going to be equal to 150 centimeters over x, because 150 centimeters, remember, represents the diagram length, and x represents the actual length, which is what we're looking for. So now, being that you have the equality of two ratios, you have what is called a proportion. And once you have a proportion, then what we can do is we can cross multiply to solve for our variable. So I take 50 times by x is equal to 3 times by 150 centimeters. And if I go ahead and divide both sides by 50, I come out with 3 times by 3 centimeters, which is 9 centimeters. Now the one thing that you need to notice about this is that I included the units of measure. And the reason why I'm including the units of measure is because our scale ratio does not include any units of measure, and so we need to be careful about what the unit of measure that we're dealing with. Now once we get 9 centimeters, we need to go ahead and convert that to meters. So I'm going to go ahead and again use a ratio to convert 9 centimeters to meters. And I'm going to say that 9 centimeters to x meters is 100 centimeters to 1 meter, because this is the conversion factor between meters and centimeters. So if I cross multiply again, I get 100x is equal to 9, divide each side by 100, and then come up with 0.09 meters. Okay, so let's go ahead and wrap up and let's summarize. Again, remember, scale factors are numbers or ratios that we're going to be able to use to describe enlargement or reduction. In order to determine scale ratio, we take the ratio of the diagram length to the real life length and ensure that there are no units. And the scale factor is just going to be the reciprocal of the scale ratio. Now, once we go ahead and apply scale ratio or scale factors to particular problems, we need to just be very careful about our units of measure, as that needs to be accurate. Okay, so we'll go ahead and we'll take a look at some of the problems in class, and we'll also go ahead and answer this question with regards to the relationship between the image and the real life based upon these different values of scale factors. So we'll see you the next time in class. Take care. Bye-bye.